All right. So Vikram Jaswal is Associate Professor of Psychology at the University of Virginia. For many years, his research focused on language and social cognitive development. He has served as the Associate Editor of Developmental Psychology, Secretary of the Cognitive Development Society, and as a Program Officer at the National Science Foundation. He received his BA in Psychology from Columbia University, MSc in Neuroscience from the University of Edinburgh, and PhD in Psychology from Stanford. Dr. Jaswal will discuss the strong belief children have in testimony, which can even override obvious contradictory perception. Please give a warm welcome to Dr. Vikram Jaswal.
Thank you. Thanks, Eric, and for organizing this, and thank you all for your attention in advance. My own research program has transitioned to focus on other topics, but I'm still really interested in testimony and credulity and many of the things that are being addressed here today and yesterday. So thank you, Eric, for kindly allowing me to come along, even though I don't do much of this work anymore. And that's also why I have my notes here, because I might not remember what this is all about. So I'm a developmental psychologist who kind of stumbled onto Spinoza and belief just in a roundabout way. First, let me thank a couple people. Of course, this is Chris Edgar. She's a collaborator on the second study I'll tell you about, and that's undergraduates and graduate students in my lab. So I stumbled onto Spinoza and belief in a roundabout way, in the sense that I was initially interested in questions about categorization and how children make inferences from categories. And eventually I ended up asking questions about how children learn about non-obvious categories. How do they learn that penguins are birds, for example, even though they don't look much like typical birds? Or in the picture on your right, how do they learn that legless lizards are lizards, even though they look a lot more like snakes? And I guess the answer is obvious. They learn about a lot of the world, including about non-obvious categories, from other people. From what other people tell them, from what I'll call a testimony. And we heard yesterday that also kids and adults learn that the earth is round rather than flat, even though their own perception of it is their own perception, firsthand observation of it would suggest that it's flat, that they learn that it's round through what other people tell them. And so I became really interested in these counterintuitive cases, like the legless lizard case, or like the earth being round even though it looks flat. And I got to wondering, what does a kid do when their own self-generated belief on the basis of observation or perception or something like that, what do they do when it conflicts with testimony, conflicts with what somebody tells them? And intuitively, to me, it felt like your own first-hand belief should be stronger or more salient or something than just just what somebody else tells you. And this is captured well in a quote from Susan Gelman of the University of Michigan. One might expect children to be deep down empiricists, believing most powerfully in what they can see. Again, it seems intuitively right. When you're faced with this conflict, you've seen this, you've experienced this, and then you're just faced with somebody. Maybe sometimes a strange adult is telling you something. Why on earth would you believe what they tell you? But then in study after study after study, Susan and I and many, many other people, and any parent will tell you that kids are pretty credulous. They believe a lot about what they're told. And what we have found, and others too, when testimony is offered by a single adult speaker in a confident manner, kids are pretty willing to believe what the adult tells them, even when it's moderately discrepant from what they already believe. I'm not the first person to have noticed this. Obviously, it's Reed, who we heard about yesterday. Thomas Reed mentioned his principle of credulity. Other people have talked about it too. Dawkins, here's a quote from Dawkins. Theoretically, children might learn from personal experience not to go too near a cliff edge, not to eat untried berries, swim in a crocodile-infested waters. But to say the least, there will be a selective advantage to child brains that possess the rule of thumb: believe without question whatever your grown-ups tell you. So I came to believe, informed by these folks, that maybe kids have a bias to believe what other people tell them. That's their default. Belief is their default. So today I'm going to tell you about two studies that look at this. One is just an attempt to document or demonstrate that children have a robust, highly robust, specific bias to trust testimony. And the second is to demonstrate that not believing what somebody says for children is an effortful process. I think it's really important when a bias is invoked to explain some aspect of children's or adults' behavior that you ask, a couple of important questions. One is, do the benefits of such a bias outweigh the costs? And I think Dan said this very well in his American Psychologist paper. I think in the case of testimony, in the case of what other people tell you, for children especially, it's yes, I think almost certainly the benefits outweigh the costs. Most of what children hear, I think, is likely to be true. A lot of people have pointed out, Reed's principle of veracity, or Bryce, we heard about before, Dan Dennett has pointed out the faculty of communication would not have gained ground were it not for the fact that usually it involves a transmission of true beliefs. And so we don't have the time or the expertise to evaluate the veracity of most of what we hear, and most of what we hear probably is true. I think especially true of children. I think there are exceptions, of course, death, sex, and so on, you might not talk about with young kids. So there are huge benefits and relatively few costs, although the cost can be, of accepting this information can be deadly, obviously. The second important question to ask is, where does this bias come from? Maybe what I and others are referring to as a bias to believe testimony really reflects a general undifferentiated trust in other people. As Annette Beyer pointed out, the philosopher, children are totally dependent on other people. And so, of course, perhaps they just trust that other people will treat them in helpful or at least benign ways. She said, children can make suspicious, futile, self-protective moves against the powerful adults in their world, but surviving infants will usually have shown some trust, enough to accept offered nourishment, enough not to attempt to prevent close approach. So we set out, in the first study I'll tell you about, to investigate whether children's willingness to believe what they're told, even when there's a penalty for doing so, represents a bias to believe testimony specifically, or maybe it represents some more general, undifferentiated, diffuse trust in the goodness of other people. Other people are going to be helpful. So we asked this question by comparing children's ability to resist misleading testimony, that is the spoken verbal testimony of an adult, with their ability to resist misleading information, the same misleading information conveyed in a non-testimonial manner, which I'll explain, of course, in a second. And the hypotheses were, if 3-year-olds are misled to the same extent in both of these conditions, then maybe it is just some general undifferentiated trust. However, if they're misled more often by testimony, then maybe there's something to the idea that they have a bias specifically to believe what other people tell them. So how do we do this? We brought 3-year-olds into the lab. This is kind of a bird's eye view of a table. You can see the experimenter, labeled with E, is sitting across the table from a child who's seated next to the confederate. And also on the table are 2 cups. There's a red cup and a blue cup. We use lots of different colored cups. The experimenter explained a game to the kid in the following way. I'm going to hide a sticker under one of these cups, and then I'm going to let you look for it. And if you find it in the first cup that you look under, you get to keep it. And if you don't find it in the first cup you look under, I get to keep it. And we weren't aiming for subtlety here, so the experimenter said, I'm going to try to get as many stickers as I can. How about you? And at various points during the session, the confederate sitting next to the kid would say things like, so-and-so's being really tricky, isn't she? So at this point, the experimenter would put in a cardboard screen between herself and the child and hide a sticker under one of the 2 cups, in this case under the red cup. Then she would remove the screen, and in the misleading testimony condition, she would say, it's in the blue cup, naming the cup opposite to the one that she had just placed the sticker under. And this was repeated 8 times. So remember, if the kid finds the sticker in the cup that they look under, they get to keep it. If they don't, then the experimenter gets to keep it. And of course, give all stickers to the kid. So that's the misleading testimony condition. So how are we going to convey the same information in a non-testimonial manner, at least in a non-verbal testimonial manner? We did this by using an arrow. Really, it was just a cardboard arrow cutout that the experimenter, instead of saying, after she baited the red cup out, instead of saying it's in the blue cup, she placed an arrow on the blue cup. And that happened 8 times. All right, so let me show you first the data from the very first trial. So on the x-axis is trial number 1 through 8. On the y-axis is the number of children out of 16 who found the sticker on a given trial. And on the very first trial, no child in either the arrow or the testimony condition found the sticker. They all were misled to look under the cup that had been mentioned by or pointed to by the experimenter with an arrow. But you can see that on later trials, you get this divergence. So in the testimony condition, that's the dotted line, you can see that very few children on any of the trials searched in the cup that was opposite to the one that the experimenter mentioned. And sort of qualitatively, it was almost as like they couldn't help but look in the cup that she mentioned, even though that meant that they didn't get the sticker. And in fact, 9 of the children in this condition didn't get any stickers on any of the trials. They're happening one after the other after the other. And in contrast, you can see that in the arrow condition, after the first trial, where maybe they have some general undifferentiated belief in the goodness of other people and the helpfulness of other people, but after the first trial, these kids in the arrow condition had learned that a reverse contingency was in effect, that I should look in the cup that's opposite to the one that the experimenter was marked. So, I think kids' difficulty in the testimony condition relative to the arrow condition does suggest that in addition to whatever undifferentiated trust they have in other people, and I think they may expect other people to treat them well, they have a specific bias, highly robust, to trust what other people tell them. And this stems from the normally reasonable expectation that what other people say is true. That's a very heavily entrenched expectation, much more heavily entrenched than the expectation that where somebody places an arrow is likely to be true. So, I want to tell you about a second study which focused on if kids have this highly robust bias to believe what other people tell them, that overcoming that bias should require effort, should require some cognitive effort. That is, responding skeptically should require inhibiting this normally appropriate bias to believe what you're told. So in this study, we presented 3-year-olds again with a situation where the information that they were provided by a verbal testimony conflicted with an event they had just witnessed. And for various reasons that I won't go into now, we use this apparatus, which involves these 3 chimneys up here affixed atop 3 cups. And each chimney can be connected to a cup using, in this case, a clear tube. And you can see that this cup up here is connected to this, this chimney up here is connected to this cup. There's no, again, no deception involved in the apparatus itself. So, and furthermore, you can watch as like a goldfish cracker, which is a very exciting thing for a 3-year-old, travels down the clear tube and lands in a cup. All right, so what happened was the experimenter would drop a goldfish cracker through one of the tubes. It would travel down the tube and land in the cup. The child would indicate at that point where the goldfish cracker was, and then a confederate seated next to the child would name a different location. I call it the gravity location, it doesn't matter, but name a different location. So providing conflicting testimony with what the child has just witnessed. Then the experimenter, sitting across the table from the child, would look at the child with a puzzled expression on her face and essentially ask the child to resolve this contradiction. So where should we look? And the question was, where would the child indicate to the experimenter that they should look for the goldfish cracker? And once again, there was a penalty for deferring to what the confederate said. Because if you find the goldfish in the cup where you search, in the very first cup, you get to keep it and eat it. And otherwise, it goes to the experimenter. Okay, so this happened over the course of 6 trials. We're interested in where they look where they indicated initially, just to make sure that kids could follow the trajectory of the tube and understand that the goldfish cracker would land in a particular cup. And so this just demonstrates that almost 90% of the time across these 6 trials, children indicated that the goldfish cracker had fallen into the cup that it had indeed fallen into. So then the Confederate offers this misleading testimony, and the experimenter asks the child to resolve the conflict. And here are the data. So you can see that we get a pretty dramatic drop in the likelihood that they indicate the actual correct cup, and a concomitant increase in the likelihood that they indicate the cup that the Confederate had just mentioned. So some children clearly had difficulty not believing what this Confederate seated next to them had just told them about this event that they had just witnessed. I think it's important and sort of crucial to this experiment that it was just some children. So this is a figure that shows you the number of children who deferred to the experiment, to the Confederates' misleading testimony on 0, 1 to 2, 3 to 4, 5, 6 trials, right? So deferential children over here, skeptical children over here. You can see about 20 kids never deferred to the Confederates' misleading testimony. They stuck to their guns. They saw that goldfish cracker fall in that cup. Doesn't matter what the other person says. And then, about 15 deferred on all or almost all of the 6 trials. And so we're interested in what distinguishes these 2 groups of children. Essentially, we call the kids over here who deferred 3 or more times, we call them deferential, and we call the kids who deferred fewer than 3 times skeptical. And what are some possible reasons why you would have deferential and skeptical kids? Maybe it has to do with age, maybe it has to do with gender balancing, but those things didn't matter. What we looked at was inhibitory control. So by inhibitory control, I just mean the ability to inhibit a prepotent response. If the prepotent response is belief, then maybe inhibiting that belief would be difficult. The way we measured inhibitory control in these kids was, well, let me tell you about what the 2 possibilities are first. Okay, one is consistent with the sort of Gilbertian model, and one is not. One possibility is that it's the deferential children who have higher inhibitory control, because they have to inhibit responding on the basis of their first-hand observation in order to go along with what the adult has told them. That's one possibility. The Gilbertian approach would be it's the skeptical kids who have higher inhibitory control. They have to inhibit responding on the basis of what the experimenter or what the Confederate told them and go with their gut instead. Right, this is the one that seems intuitively correct, as I mentioned on the first slide, and this is the one that, the direction in which we've been arguing so far. So the inhibitory control task is one that's a spatial conflict task. It requires kids to help a Sesame Street character find his way home. Essentially, 16 of the trials are what we call compatible trials. All the kids have to do is push the house that matches the target presented above. Compatible because Bert, right? Bert is appearing above his house, so it's spatially compatible. There are also 16 incompatible trials. Bert appears above spatially the opposite house, so kids have to inhibit a prepotent response to respond on the same side of the screen as the target has appeared. Generally speaking, incompatible trials are more difficult than compatible trials. You get more errors. So we can look at these data by calculating interference score. So in this calculation, essentially it's asking how much easier did kids find the compatible trials relative to the incompatible ones. And a higher number represents that you found it easier to do the compatible trials than the incompatible trials. So you had more difficulty with the inhibitory control challenge posed to you by the spatial conflict task. Score of 0 means you found it equally difficult or easy, and below 0 would be the opposite. And here are the data. So you can see that the skeptical kids, they're the ones who found the compatible trials to be about as easy or hard as the incompatible ones. They got about the same number of each correct. Deferential kids, though, had more difficulty on the incompatible trials than on the compatible trials. They seemed less able to navigate the inhibitory control challenge that's posed by this particular spatial conflict task. So what this suggests to us is it provides some evidence to suggest that it's the skeptical kids who have higher inhibitory control. They have to inhibit responding on the basis of normally reliable testimony. So it probably doesn't surprise most of you that kids are pretty credulous. They believe all kinds of things, like, you know, a fat man in a red suit flies through the air, in a sleigh pulled by reindeer. They believe that the Earth is round, even though their observation of it is that it's flat. But I think the depth and sort of resilience of their willingness to believe is pretty surprising. Even when there's a penalty for deferring, these kids in these experiments, many of them, not all of them, many of them continued to believe what the experimenter said. So obviously one goal in development, one process that has to occur is the development of a healthy balance between skepticism and belief. And I think this isn't just a goal for child development, it's a goal for adult development too. And I look forward to learning more about how we can achieve these results in the next few sessions. So here's my final correction. Thank you.
Let's open up to questions.
Thanks for the talk. It's really interesting and thought-provoking. Another sort of consideration that obviously comes to mind is that part of what's going on here is not them believing what the experimenter said, but basically weighing that against some kind of like impression management. You know, you just don't want, the child doesn't want to be put in a situation where the adult might have a bad opinion of them because they're disagreeing with the adult. And here the act of disagreeing with the adult is basically correlated with you indicate, you know, your behavior indicates something like a belief. And so as a thought experiment, or maybe you've done that, what happens if you take that out of the equation, that is the adult, you know, makes the statement, but then there are no consequences or impressions. The adult leaves the room, or the confederate leaves the room, and then the child is left to do whatever they want. What happens then?
Yeah, that's a great question, and one that we struggled with for a long time. So in that chimney study, for example, we have done a version where the goldfish cracker falls into a transparent cup rather than an opaque cup. So you can see it as it travels down the tube, and you can see it sitting in the tube, and the confederate makes this crazy claim that it's in a different cup when you can see that it's not in that cup. And then no child will defer under those circumstances. So there are some limits to deference, and that's one reason why I think it could be the case that when they do defer, they're really believing, because it's not impossible for them to disagree with this adult experimenter sitting across the table from them. Another experiment that we've done involves these hybrid animals that look a lot more like a dog than a cat, for example. We created them, and an experimenter refers to them by a label that's opposite to what they look like. So if it looks a lot like a dog, and people would spontaneously judge it to be a dog, it's not a prototypical dog, to be clear, but it looks a lot more like a dog than a cat. But the experimenter calls it a cat. We go through a few of these, and then the experimenter leaves the room, and a different experimenter comes in, and under some pretext says, "Oh, let's play a game with these." But I don't know what they are. Can you tell me? We look at how likely they are to provide the unexpected label, the one that doesn't match what they would say otherwise. And you find that about as often as they can remember what the experimenter said initially, they are likely to provide that label subsequently. So, but it is an interesting problem, like how much is compliance and how much is conformity and how much is just going along with it for the sake of social reasons. And I think that's fascinating.
So I was wondering about the developmental trajectory. So in the first study, you showed the 3-year-olds, they're okay, they won't believe the arrow, but when you tell them it, they'll keep believing it. So at what point does that stop? At what point do the kids start realizing that I should do the opposite of what the experimenter tells me?
Yeah, great question. Also, we do have data to suggest that 4- and 5-year-olds, you know, even on the very first trial, you get a lot of skepticism because of the way it's set up. So they understand the context that this is a competitive game, and from the very beginning. So at least by 4 or 5.
I'm wondering about the study with the arrow versus the explicit testimony. I'm wondering if what's going on there is that the child just reinterprets the meaning of the arrow. So the arrow itself, it does seem reasonable at first glance to think it means that the sticker is in this bucket. But it seems compatible with what you presented, that the child might just, after they see that the sticker's not in the bucket, mean, oh, that's not what the arrow means. The arrow doesn't. So it's that they're no longer processing that propositional content. So the difference could, or do you think that the difference could just be that in one case they continue to get the propositional content because you can't reinterpret away the meaning of a sentence like the stickers in this bucket?
I think your first point may be the correct one. I'm not sure. We have other work with pointing, for example, rather than an arrow, and pointing operates a lot like verbal testimony. That is, kids have a really hard time not looking where somebody points in exactly the same paradigm. And I think the reason is because they have a lot of experience with pointing serving as a veridical indication of where something is. And so it could be the case that they have interpreted the arrow to mean something different, and this is where something is. Yes, I agree with you.
Wondering about just longitudinally for the kids that are skeptical, do you see that they turn into having traits of being adults that are more skeptical, or being naysayers, or any of the general constellation of anti-acquiescence traits we see?
Well, we haven't been able to follow up with, on these kids, and so I don't have an answer for that. But thinking about the way that we sometimes think about the work was, how you foster critical thinking, the development of critical thinking, and we considered the possibility that maybe providing training in executive function and inhibitory control would be a good thing to do. It seems like it's good for everything else. It would be good for this too. So, but I don't know whether that's true.
So you talk a lot about kids have specific robust bias to trust what other people tell them, and I wonder if is it people or adults. So what if it was another kid, slightly older kid, because you'd have to get the kid to act like the experimenter, right? Is it really about is it about thinking that the adult has more knowledge than them, or is this more about conversational conventions? Like when someone says something, it's most likely to be true. In which case, it would work for a kid versus an adult, or an adult. Alternatively, if it's about knowledge.
So we haven't done these kinds of experiments where there's a conflict between perception and testimony with kids versus with a confederate versus an adult confederate. But I will tell you that when two speakers are pitted against each other, naming a novel object, like an adult says, that's a blicket, and a child actor says, of the same, roughly the same age as the participant, the child says, that's a toma, and then you ask the participant, well, is it a blicket or a toma? The default is to go with what the adult said, unless the adult has been wrong in the past and the child has not. Like if the adult has referred to spoons and cups and dogs with incorrect labels, then they will go with what the kid says. So they are very sensitive to information about who's been accurate in the past, and they're very sensitive to age. Yes, and then one other piece is that they do seem to have expectations about who knows what kinds of things. So again, not in this paradigm, but they expect in the other work we have that testimony from adults about nutrition is likely to be correct, whereas testimony from children about what toys are fun to play with is likely to be more correct than the adults' version.
Super interesting, thanks. So it seems like a big difference between study 1 and 2 is that 1, the experimenter has a motivation to say something wrong, so they're lying. Study 2, they could just be wrong, right? They'd have no motivation. So I wonder if at least study 1 you'd have to have you in mind, and that's why, which I'm mindful that's my college, but I understand the kids don't have it until around 4, so at 4 they would understand that they have motivation instead of lying, that they could easily.
The theory of mind literature is beyond my understanding also, but I do think that based on what we have research that we have with the 4 and 5-year-olds who almost immediately don't believe what the experimenter says in the study 1-like version. I think that suggests that they do understand, they do better understand deceptive contexts than do the younger kids.
Any other questions? All right, another round of applause.